Hey, what's up guys? Today we're going to be talking about implicit differentiation. So implicit differentiation is basically an application of the chain rule. So I'm going to first use just an example that's really simple. We're going to use y is equal to x squared. We're going to try and find the derivative. Now when we find the derivative on this side, right, and we're going to do it with respect to x, the way we write our answer is the derivative of y with respect to x is equal to 2x. So the question becomes, why is it that this appears with the derivative sign and this doesn't? That is because we're taking the derivative of y with respect to x. Now this you can imagine as being multiplied by the derivative of x over x dx, which is just 1. That's why we never really write it. Now let's just review the chain rule for a second. The chain rule says that we can split up this dy over dx into dy over du multiplied by du over dx. So we have two derivatives being multiplied by each other to equal the one initial derivative. Now the reason why this is relating to it is because we have to take into account what we're finding the derivative with respect to. If we're finding the derivative of y with respect to x, then you have dy over dx. If you're finding the derivative of this with respect to x, you just take the derivative because the variable is already x. So let's take an example here. Just going to find the derivative of y squared with respect to x. Now the way you would do this is you can split it up into, using your chain rule, the derivative of y squared over dy, and then multiply it by dy over dx. As you can see, they're the same because of the chain rule. So the derivative of y squared with respect to dy is just the same thing as finding the derivative of x squared with respect to x. It becomes 2y. So you have 2y dy over dx. And the second reason why it's a lot like this is because what you're doing here is you're finding the derivative of every single term. So let's take, for example, the last one here so that you can fully see how implicit differentiation is taken into account. When you're trying to find the derivative of a circle, so let's say you have x squared plus y squared is equal to 5. Now, using implicit differentiation, you'll see that it's just 2x because you're finding the derivative with respect to x. And you have implicit differentiation, so you have 2y times dy over dx for this reason over here is equal to 0 because the derivative of any constant is just 0. Now, after this, you're going to have to isolate the dy over dx. You didn't have to do anything here because it was already isolated, but here you want to isolate it. So the 2's will cancel out. You can just divide 2 on both sides. And what you'll end up getting is that you'll have dy over dx is equal to negative x over y once you rearrange your equation. And that is your derivative using implicit differentiation. A lot of the time, and almost all the time, you'll end up with this y in either the numerator or denominator, and that is because the y appears here due to implicit differentiation. You don't automatically go to dy over dx. I hope you enjoyed this video. If you enjoyed it, please give it a thumbs up and subscribe, and I'll see you tomorrow.